I checked the back. I don't think so because I think someone broke my stapler.
Yeah, it is back.
Yeah, it is back. Is it working?
Yes.
Woo! Someone fixed it.
So you doing part 1 and part 2? The weekend? Yeah. Yeah, exactly. I'll do part 2. Oh my
Put on
god.
that there. I have to go grab one thing.
Shut up, dude.
Chemical energy is height times
Oh, yeah.
Wait, is it May?
Huh?
Yeah, that's in 2 flipping days.
2 flipping days. What's 2 flipping days?
Oh, English project.
I didn't see it.
Nope, I have a question. Everything on the
No, I used up. William asked me 2, and I only had space for 2 today.
If I hand these in by like today,
Oh, a lot of those questions are just going to be answered right now. The answer is short answer though is no. For everybody else yet, but just not if you're new to sing. Because I expected more of you. Dave. I'm so disappointed.
it's just the last question.
Okay, if I can get your attention. These are the people that I would expect would have the 4.1, first one in there. For those of you who already had it in on the process of marking it, the mark will come up on zip grade if you want to see how well you did once I'm done. And then once I can hand it back, you can see how I marked it.
I have mine.
And I did one second. So the ones I believe I need for 4.1 are Timmy, Felix, Zane, Birdie, William Wren, see here,
I just gave mine.
Hugo, again, Hugo, and then that's, I think that's it. Pull it. No, Hugo, you're good. That was the first one. Yeah, if you put, those are the people that should have put it in there. If you did, you're good. Now here are the people that should have put 4.2 in there. Everybody except for Lisa. Does anybody else think they handed in 4.2? No? Okay, those will also go up on zip grade once they're all marked, and once I have them all, I can give them back. Yes?
Do you have a zip grade logins?
Oh, yeah, it's been a while. I'll get them. I promised Science and Ethics I'd get for them too. So yeah, I'll print them off. Maybe, we might have time this block. Yeah. Oh, yeah, I won't make you walk over that. Unnecessarily cool. Okay, please put away everything off of your desk except for a pencil and an eraser. You have a surprise quiz. No data booklets.
Wait,
Your brain and an eraser, pencils only, no pens.
do we have the one test?
This is a quiz.
Yeah.
Put everything away. Everything away. Quick. Everything off your desk. Everything off your desk. Pencil and eraser only. Pardon? No calculators. Oh no, you can have a calculator. Sure. If it makes you feel better, you can have a calculator.
I'm not that smart.
Yes, you are. Everything off your desk. Then you'll have to use your brain. Long division, slow multiplication. Why didn't you have a calculator?
Not faith in yourself, you would pass.
Oh, okay. But you have
It's
one.
only,
Like,
it's only faith.
does anybody here not have a scientific calculator? Like anywhere? Okay. Remind, because you'll need one.
Oh, we do.
Okay, sure. Okay, is everybody? Oh, that's my bad.
The math one and the science one?
Don't start doing this. No data sheets. Don't start doing it. But no, what are you doing? Just put those away. You don't even need them.
Is this formative?
Absolutely pardon?
Is this formative or?
It's
What the hell is this? Significant figures.
formative.
Oh, it's just science notation.
Guys,
Everything's a learning experience. Everything always counts.
I don't know, it's not the direct exercise.
Now, I would like you to take this sheet. Take it. Turn it around so the blank side is facing you. And I'm going to give you a few notes. Because scientific notation, I'm assuming, is review from math. So we're just going to do some scratch notes on scientific notation. And then you're going to practice it on the reverse side.
We haven't done that.
haven't done scientific notation.
Well, if you haven't, you're about to learn it. You should have done it in grade 9. How many of you did do scientific notation in grade 9? Some of you have. Some of you have. So let's do the full word there. Scientific. Leave room. Scientific notation. If I have a number like 0.00000000602, that doesn't fit on your calculator. It goes 1, 2, 3, 4, 5, 6, 7, 8. So your calculator will spit it back inside your notation. Can anybody tell me what that is inside your notation? Yes.
602 times 10
602 times 10
to the power of -8.
to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. No. You could write 0.0602 times 10 to the minus 8, but that's still not scientific notation. And this would actually be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could write that, but neither of those are scientific notation. But already we are demonstrating the first rule. If you look at a number, and if it's a regular number, and you're going that way, you get a negative exponent. So, does anybody know where we should go to? That way? And where should we stop?
6.
6. Before the 6 or after the 6?
After.
After. So you just go, get a nice thin line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We go to minus 10. So that number is actually 6.02 times 10 to the minus 10. Does everybody know what a negative exponent means? If I say x to the minus 1, what does that mean? Yes?
1 over x.
1 over x. So when we say 10 to the minus 10, we just mean 1 over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is a very small number, which makes sense that if you took the regular number, 6.02, and multiplied it by that, or divided by that number, you'd get that decimal. So it's just a way of representing numbers extremely compactly. As well, we can have 602,590. Yeah, what would that be inside the notation? Pardon?
6.
Yeah,
No,
there's scientific efficiency.
is it 6.0259 times 10 to the power
Times 10 to the power of?
1?
Not 1.
Power of
Now here, you could see the decimal. The decimal is really big, and we could see it. Where is it in there? Yeah, so it's there.
10 to the power 6.
So, yeah, well,
5.
1, 2, 3, 4, 5, plus 5, times 10 to the 5th.
Wait,
Yes.
why would you put the last zero though? Can you?
Oh, good point. Now, there was no decimal there, right? Like when I started, there was no decimal. So this number, that 0, no county for this. You take that 0 off. However, if I wrote 602,590 decimal, and I wrote that, I didn't put it in afterwards. And, what does that equal to scientific notation? Yeah.
6.02590 times 10 to the 5th.
Yeah. These are the same number. It's just whether or not we include the 0. And we don't include the 0 here, and we do include it there for something called significant figures, which I'm going to do next. Significant figures are a way of determining what's true. It is literally about big T truth. What's truth? When you measure something, what's the truth? If this person measured that, they didn't put a decimal there. Let's say they were measuring, the weight of a barge. It's 602,590 kilograms, plus or minus 10 kilograms. So that 0 doesn't matter. There's never a digit there. But if we put that decimal, that means we measured exactly. The height of Mount Everest ends in 2 zeros, and they used to add an extra 8 meters to it because they just figured nobody would believe that it actually ended in 2 zeros because people don't understand sig figs. So if you are moving this way, you are getting a negative times 10. If you're moving that way, it's a positive times 10. And if I have 6.022 times 10 to the negative, not negative, let's make that one big, times 10 to the 7, express that as a normal non-scientific number. And if I have 3.1459 times 10 to the minus 4, express that as a real number. Oh, am I recording? Yes, excellent. Dojo. Attendance. Alejandra, Ariel, Ben, Birdie, Felix. Not here. Hugo, he's here. Jonathan, and Kieran Porter. And not here. And Lisa, and Naomi, and Sakir, and Ren, not here. Zane and Joe. Okay, volunteer. You just answered the last one. I was going to go for you. But you've answered one as well. You've answered one. I don't think you've done one yet. Have you done one? Okay, go.
60,220,000. 000.
1, 2, 3, 4, 5, 6, 7. Perfect. And volunteer for the next one. Dave hasn't done one.
I'm gonna say 0.0003145.
Perfect. I always remember it as this is the number of zeros I have to add, so it'd be like 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And this, when I have that, is one more than the number of zeros. So if I see -4, I know there's 3 zeros have to come in here because you have to account for that one. Okay, on the front of your sheet, do questions 4 and 5.
When you go with the phone.
Questions? Exactly. Questions? When we were doing it just now. So, if you have -4, you take, when you're going back to regular number, you take that number and you go this way. So, you see minus up there. 1, 2, 4, you go 3, 0. Right there you go, you roll for 1. You go another. 3, 4. That's it. That's how we got it. There was a part of it, you're going the other way. Oh, you could put it, but if you write 0.1 or 0.1, they're the same number, right? So that number is just there for your visual pleasure to like indicate that it's a. When you're going the other way, you want to convert it into a semi-notation. Take that, there's the decimal, you just count until you get past it. 1, 2, 10. And that's why that's minus. So small numbers, one that we minus. Big numbers, one that we plus. Because now you know, whoa, this is a 10 to the try like that one and that one. Oh, so in any number, they don't tell you where the decimal is. Where is it?
So it'd be like 6 times.
Yeah, right after the last six. So there's the decimal. Yep.
I have a question. The last one, number 4. Like I wrote this one.
Do you think it makes sense?
10 to the power series 1.
So mathematically,
Yeah, but I know that. You know what I mean?
I don't mean,
Because 6.0 and 0, like after the letter 6.0
Well,
or 0.0.
I know what we could do.
Sure thing.
You could,
Could we in that case use 6 times 10 divided by 0?
you could,
Look at you,
no, 10 divided by 0 is,
No.
no. it's
No,
not,
10
it's empty.
To
elevated
the
by
power
0.
of 0. Like,
No. Yeah, so why don't you put the answer in, then we'll mark it.
so this.
Yeah, that one. You're responsible for that one.
¿Te gusta eso?
Pick, each of you pick one on there. So I've got 1, 2, 3, 4, 5, 6, 7.
I'm tough like
You've
that.
answered one. You've answered one. You haven't answered
Control your
one,
hand.
so you can go up and answer one. You answered one? And like in the question mark? So you could go up and do one of those? The scientific notation is always number,
Especially like a fidget.
dot, number. So you stop moving if you have something like this, when you hit that first digit. Then it's a number dot. Yeah, the first two numbers. And if you start inside notation, that number is held. Always done. Jimmy, you go to one. And anyone that's left.
Oh, she literally cooked it.
Okay. Well, you go to one. How's it going? Okay, so little eraser is right there. Oh, pick this. Oh, it's on the smallest one. And just, there you go. Pen. Is that, what number is that? He might need to redo it. Wait. Oh, perfect. Why don't you go write that one over there? 4B. Oh, yeah, absolutely. Excellent. Oh, and Bernie, to answer your question, so when you're going this way, you did it exactly right. You had the decimal there, and you moved to a 1, 2, 3, 4. So perfect.
Yeah, because I know things that like can y'all follow, so just text.
I really appreciate it, guys. I really
Yeah,
appreciate
that.
it. He's like,
He
can
didn't send it to you?
follow?
The monster propaganda, the after
I guess it's not like this, it's like this.
Yeah.
Okay. 1.5 times 10 to the minus 8 looks good. If I can get attention, Lisa, Alejandra. 1.9 times to the minus 4, 7.4 times 10 to the 3. Now I am going to quibble here, but only for sig fig reasons. That will become apparent mostly. As I went over, because the decimal's there, you do have to keep the zeros. It's pedantic. You are correct. Times 10 to the 0. If you don't move it at all, you moved it 0 times. And anything to the power of 0 is 1. So it's 6 times 1. So that is technically the correct scientific notation. 13,000, 1.3 times 10 to the 4, 3,850,000 times 10 to the 6. 1, 2, 3, 4, 5, 6. Perfect. And 0.008 grams. And so that's our scientific notation. Now, sig figs, I'm going to do briefly. So, new title, significant figures. And they exist, and we worry about them because they reflect our accuracy. If you saw this skull sitting in a museum, gray with age, not because I 3D printed it from a scan of the original skull. This is the earliest hominid ancestor that we are aware of. It's roughly 3.8 million years old. Well, this is actually only a couple of years old, but you know what I mean. If this is sitting on a shelf, it was the original one, and a museum attendant came up to you and said, that skull is 3.8 million and 12 years old. And you say, wow, you know that with such precision. How do you know that with such precision? Well, the label says 3.8 million years old when I started working here 12 years ago. So it must be 3.8 million plus 12 years. And that, of course, is nonsense. Because it's 3.8 million plus or minus 100,000. 12 years is nothing on that scale. It doesn't even register in the error. We have to know where our measurements stop. Because if we trust our measurements too much when there's actually a great deal of variance, if your bridge is supposed to carry, up to 100 metric tons, that's how many trucks and freighters and cars that should be able to do that. And you build the bridge so that it can carry 100 tons plus or minus 10 tons. Would you trust that bridge? No. How much? What might it only be able to carry?
90 tons?
Pardon?
90.
90 tons, in which case that bridge is going to fall down. We want to know where our error begins. And so there's a lot in science about measurement, and when you take a measurement, and where that measurement begins and ends. So if we have a number, and I say, I weighed something, and it's 5.63 grams, we say that this has 3 significant figures. We have 2 known. We definitely know that it's 5.6. And we have 1 guess. Because it's 5.63. You ever stand on a scale or weigh something or measure anything and that last number's flickering on the digital scale? That's the error. There's error there. We don't know what the error is. So that's always considered a guess. If you don't know the error, it's considered to be plus or minus 1 in that digit. So this could be anywhere from 5.62 to 5.64. This is why in science we're allowed to say that 2 plus 2 equals 5 for very large values is 2.
What do you mean very large values of 2?
Well, if I take a measurement, like, this is going to be an aside, you don't have to write this down, but if I take a measurement and it weighs 2 kilograms, I don't have any certain numbers. I don't have any known numbers. I just have 1 guess. This is 1 sig fig. So this is 2 plus or minus 1 kilogram. So what could it be? What's the highest it could be?
2.1.
No, plus or minus 1 kilogram. It could be 2.1, but what else could it be? Could be 3. This is anywhere between 3 kilograms to 1 kilogram. So 2 plus 2 can equal 6 for very large values of 2. It can also equal 2 for very small values of 2.
So it's just a guess.
Why do you, so it's just guessing?
It's just well, all science is guessing. At some point, you reach the end of your instrument, and that instrument is taking a guess at the last decimal place.
How do you know what to guess? Yeah.
Oh, it'll be dividing your instrument. So grab that meter stick beside you. Chuck it here. Well, not that. Well, I like
Don't like the way you.
I like you throw like this, so it whips and rotates as opposed to something like this where I can catch it. If I was to guess on this side, you've all seen these. What's the smallest measurement on here?
Millimeter.
Millimeter. So if I measured it in the nearest millimeter, those are all certain, but there's a gap in between the millimeters. If I measure in between the gap, I have now taken my guess. That's the guess. And we know it's in there somewhere, so that's why it's a guess. And humans are pretty good at dividing things up into tens and then taking a guess. So we always assume plus or minus 1. If you say it's, 4.4, and now you're guessing in between, 5 is halfway there, then that 5 is considered a guess. It could be 4.4, 4.46, anywhere in there, but it shouldn't be otherwise. If you were to do it here, your guess is a lot bigger. Because you're guessing on what? Is it inches? Oh God. Imperial units. You'd be guessing in between 1/8 of an inch. And that would be your decimal. Now, if we were in Chem 11, I do a lot more on the different types of guessing and measurement and burettes and all sorts of other things. But all I really want you to do is come away with a sense of how to count significant figures. It'll make it much easier next year, whatever science you choose to go into. And how to multiply them and maybe how to add them. So if I have, what about 502 grams, how many significant figures are in that?
3.
So yeah, but you don't have a phone, but you're just acting like your calculator is your phone. Stop playing Brawl Stars on your calculator. How many sig figs are on this? See here? How many sig figs are there?
3.
3 sig figs. Excellent. I'm not going to write sig figs ever again. I'm just going to write SF. If I have 500 grams, how many sig figs are there?
3.
No. 1.
I don't get that part though.
Yes?
But would it be 2 significant figures in the first one if there's only 1 significant
Yeah.
figure?
Yeah.
No.
Why?
Because there's 2 zeros.
How do you know you measured that? We have to write the zeros because they show you how big the number is. So if there are 3 sig figs, we would write it 5.00 times 10 to the 2 equals 3 sig figs. 5.0 times 10 to the 2 equals 2 sig figs.
Wait, why?
And 5 times 10 to the 2 is equal to 1 sig fig.
I don't get it.
But this, what we really say with this is we say bad form. Because they didn't put the decimal there. I don't know if this is maybe this is a scale that only measures to the nearest 100 grams. So it will tell me 500 grams, 600 grams, 400 grams, but it won't give me anything in between. Maybe this is a scale that goes to the nearest 1 gram. So it could go 501, 502, like the other one. But we don't know because of how our number system works. If that's a 2, we know they measured that. But if that's a 0, it might just mean they had to put it there to show how big the number is. Because if I wrote 0.5 kilograms, oh, let me do it this way. If I have 0.5 kilograms, How many sig figs are in that number?
Two. Significant.
How are you counting two? How many numbers are there?
One.
One. There's one sig fig.
But you said if it was in a.
Yeah,
you
there's
said
a
if
zero.
decimal
Wait, no,
was
there's a. Can you write this like that without the zero?
Yeah.
Yeah, so I just did. Haha, there's only one.
So if you add a zero, it's gonna be 2?
No, if I add a zero, it's just one. You could add as many zeros as you like before the decimal, it doesn't matter. You don't have to write zeros before the decimal. They're completely arbitrary. They're only there to make your number look nice.
So then how come 502 is 3 sig figs?
Yeah.
Ah,
Because if you take out the zero, then it's 52.
if you take out the zero, it's 52.
It's fully different.
That two means I measured that, right?
Yeah.
Like someone measured. But if this was 502 grams, how many sig figs does 0.502 kilograms have?
3.
3. And that number has 3. That makes sense. But this number, 500 grams and 0.5 kilograms, are the same number.
Sorry.
I would like to record that sound. As a teacher, that's such a wonderful sound. Yes?
What about, let's say it's 0.05, is that one sig?
Oh, good question. 0.05 kilograms. How many sig figs?
2. Oh, no.
One. Oh, nice. One sig fig.
Wait, but then how come 5 times 10 to the second power and then 5, like 5.00
Yeah.
is times 10 to the second power is 3 figs, but
Yeah.
5.0 times 10 to the second is 2.
Right.
Why?
How many decimals are there? How many numbers?
2.
Do we have
But
to
you
write?
said 0 doesn't.
Oh, zeros in front never count. Because we only put them there to show the size of the number, right?
Yeah.
So we don't have to write it. It doesn't show any extra accuracy. If I went from here to here, do I write a 0 in front of that?
No.
And if I did, does it mean anything?
No.
No, that's why that one doesn't count. And it will never count. But if I write a 0 after, if I go 502.4, how many sig figs does that have?
4.
4 sig figs. And if I write 502.0, how many sig figs?
3.
4.
What?
Yeah.
Because
Yeah.
did I have to write that 0?
Yes.
I had to if I wanted to be 4 sig figs. I only did it to show you how accurate I am. I did it because I measured it to the nearest 0.1 of a gram.
So in that case, the 0 counts.
So in that case, the 0 counts.
Okay.
Okay? Now I'm just going to go back and then see here you're next. So you were asking about this one, right? Like the difference between these two?
Yeah, because like, what if you did 502.40? Would that be 5 figs?
502 point what?
40.
That'd be 4.
Yeah, that's fine.
That many?
No, like 4 and then 0.
Oh, okay, yeah.
That's fine.
That'd be 5.
Yeah, that would be 5 sig figs.
Okay,
Yeah,
that makes sense.
yeah.
Now, I have a question.
Okay, let's see, here was next, then Lisa, then Derek. Yes, go.
If we write like 500 over there and then we put a decimal point after that, does that mean that
Ooh.
that's to the exact?
So if I write 500 and then I make a really deliberate point to go like this, that means that I'm telling the person who read this that I measured to that point. That is 3 sig figs. Because it's not just, I'm not just putting the zeros on willy-nilly. Now I'm letting you know I measured it's exactly 500. Yeah.
Can you give another question? It
Uh,
has 3, but it's only 1. Can you give another example?
Of it's 3, but it's only 1.
Yeah.
But it's 3, but it's only 1. And anything, any 100, 800.
Does that have to do with the hundreds, or does it have to do with?
I could say 12,000. I could say 196,700.
It's just because it doesn't have a decimal, right?
It doesn't have a decimal. So how many sig figs is this?
1.
1. How many sig figs is that?
2.
2. How many sig figs is this?
4.
4. Okay.
But then if you add a decimal, all the zeros count.
And if you add a decimal, all the zeros count.
But if there's no decimal, then nothing.
Okay, now, Jimmy, we now encounter a problem with accuracy. I have the number 800. It is exactly 800 plus or minus 10. That means the error is here. I need 2 sig figs. How do I make that? I can't put a decimal, so that would mean 3 sig figs. How do I do that?
You would go 8.0 times 10 to the negative 3, or negative 2.
Plus 2. Big number,
Oh,
positive.
yeah, plus 2 works.
So this is 2 sig figs. So this is one of the reasons why scientists like scientific notation. We can be very precise about our error. Does that make-
Yeah.
How many sig figs are in this number?
1.
No. 1. And how many sig figs are in that number?
3.
3. And how many sig figs are in that number?
2.
1, 2.
Oh.
Oh, that number?
1, 2.
2. That scientific notation is the only way of showing 2 sig figs in a hundreds number if there's zeros.
Okay.
Because I can't put the decimal there. That would just make it 80.
Yeah.
If I put it there, it means I measured all the way to the ones place. And we haven't, in mathematics and science, we haven't come up with a notation just to say this is where the error is. Our method is to put it in scientific notation.
Okay.
That's why we teach it to you in grade 9. And then really, we don't really discuss it again until you hit chemistry 11 and physics 11, and sometimes biology. Biology takes a while to get to numbers. They will get to numbers, and then, oh my God, the statistics. That would be impressive. So that's just counting sig figs. So zeros after, no decimal, don't count. Zeros before, don't count. But the zeros in a decimal do if you didn't have to write them, and then you do. So how many sig figs does that one have?
4.
4 sig figs. Good?
Yes. No.
Oh, yeah. Yeah.
Okay, good, okay. So, state the number of sig figs in all of those. Just number 1. This is a little illegal, by the way. Not technically in this grade 10 curriculum. When you write your physics test, if you get every sig fig you get correct on your answers, I am going to start applying bonus marks. So you can make it better.
Wait, is there gonna be questions about sig figs or if we just
I might give you some questions about sig figs,
but like if
but they will
if
always
they
always be bonus marks.
if they apply to a question that doesn't ask for them, can we just be like, oh, by the way, this makes sig figs?
You can, yeah. What I'm looking for is the right number of sig figs in your answer.
Oh.
Mr. Neufeld, for like number 2,
Are we doing
do you round? Because it say I did.
Oh, I'm gonna do rounding next. Just number 1.
So you do
Just
round?
number 1, we're done number 1.
You done?
Yes or no?
How many of you are done number 1? Bertie? Pardon? Yeah, but you don't need it for number 1. You're just counting. Put it away. Excellent. I'm gonna ask you the first one, Bertie.
Oh, so I was
Yeah.
No, it's
Bertie, how many sig figs in 734? 3. Excellent. As a class, how many in 82.400?
5.
1, 2, 3, 4, 5. Those zeros afterwards, you didn't have to write them. They count.
My apologies.
Yeah. How many in, holy crapola. How many in 92,002? Excellent. Like the peace sign. 0.003 of a second.
1 on.
1.
1.
Oh, what?
Zeros in front don't count.
Oh, yeah.
Because
I thought it was after the decimal.
0.003 seconds is the same as 3 milliseconds. Those zeros just disappear.
Wait, so if you can write in another unit,
We dialed it right.
And it would just disappear and you wouldn't need to keep it? Yeah. But if it was 0.0030,
it's 2.
it would be 2. And you'd have to keep that 0 if you put it into another unit.
Okay.
How much in 607? 3. And how much in 1 times 10 to the 4 hertz?
One.
1. Excellent. Okay. Just one. Because there's just one. Like how many
Oh, yeah,
sig figs and 5?
before.
Yeah, okay.
It's okay.
These never count for sig figs, the times 10 to them. Okay. Rounding. Your number is 1.4549. And you want to make it 3 sig figs. So that number is too precise.
1.45.
1.45. Yeah, that works. What is the rules for rounding?
If the number after is 5 or more, it goes up.
After 5 or up, round up. Otherwise, round down. So in the province of British Columbia, 86% is an A. I have a student that has 85.5 for 9999999. Do they have an A
No.
or a B?
An A,
Hey.
Why?
because you round,
No.
use a 9.
It's
I mean,
4-9. It's 4-9.
Yeah, 4-9, which can round up to 5.
But-
85.5.
Well,
and that
An
rounds
A is 86%.
Ohio.
We only have 2 sig figs in education. Our percents are always recorded to 2, to the point we actually can't record 100%. We have to put in 0 and then tell the ministry. So when we're at 5, we look over, and what number is that? 4.
4 then.
Round down.
That's what
So it's 85.4%.
But aren't those 9? Shouldn't it be 80?
Well, just also to make you feel better, if your teacher, like I saw that you had 85.4, I'm going to round it up. But we used to write, and I think in grade 10 you still write some provincial exams. Provincial exams, your marks are, if they're done with provincial exams, they're just done by a computer and it does the rounding rules. So they can do that. I know someone who in grade 12, when we had provincial exams for most of the subjects, they had 3 courses that they graduated with 85% in each. Boom, boom, boom. So sad. They'd gotten 1 extra question right in each of those exams. They'd have added 3 A's instead of 3 B's. So you only look 1 number over. You don't look the next number over, because that's too much error. Like, that could be anything. Our error is here. We only look 1 over because we're already looking beyond. If you go into engineering, they don't round this way. Can anybody think why rounding this way might be bad if you're an engineer and you're building like bridges and airplanes and Boeing? Yes.
Because if you're always rounding down on weights and so on, like if it's always like 0.3, then you can always round down, and then there might be the bridge might weigh more than
You're close, but they do round, and they would always round 0.3 down. There is a systemic error. Where do we start rounding up?
0.5.
At 5. Is 5 bigger or lower or dead in the middle?
Dead.
Dead in the middle. It's actually not a bigger number or lower number. Technically, if you have 5 and you always round up, you will introduce a very small additive error. So what engineers do is they look, if this is a 5, they look over, and if it's odd, they round up, and if it's even, they round down. Just so they even statistically weigh that number out. You don't have to do that unless you eventually go into engineering. Very quickly now, put these numbers to 4 significant figures, 3 significant figures, 2 significant figures, and 1 significant
Yeah,
figure.
but with significant figures, it just shows you measured to that amount, right?
Mhm.
So if I go 80, let's say I'm measuring to 2 significant figures, I'm only measuring to 2, which is 84. So we're not going to have any.
No. This is the number. I want you to make it 4 significant figures.
Yeah, I know. But what I'm saying is, if you're only measuring in to that amount, right? It's you have the plus or minus.
These numbers often would be calculated numbers. So you know when you calculate two numbers, they were measured to the appropriate significant figures. But now you've done your calculator gives you 8 decimals. You have to round to the right number of decimals.
Okay.
So the first one would be 84.63. Done. Now do that number to 3 sig figs, that number to 2 sig figs, and that number to 1 sig.
Because I thought with like sig fig, it's sort of like you're showing that you measured to
One
that.
second, I have a student who's trying to die. You okay? Oh, you have done significant figures, probably a fair bit. Fair enough.
Because like 84.6, if you're trying to get it to like just 2, right, it's 84 plus or minus in the next column. Or is it, right?
Yep. Yeah, well, do with them, and then we'll see what errors are made. You just start reading through this, because we're going to do that next. We have a little bit of a leg up. Actually, what time is it? Yep.
Can I leave 10 minutes early? I have to go change the kids' room.
What? Why don't you go in your uniform?
Also, it's second running, so like, I have to go change.
We are about. We're about to start something I'd like you to be here for.
Is it about like sig figs and all that?
No. I wanted to start a lab. If the lab wasn't doing use, it's apparently not.
Yeah. What's a lab on like kinetic energy and stuff?
Pardon?
Is it just on physics and kinetic energy?
We're going to be using the carts.
I can do that like next class.
Maybe. The kidlet's important. I like kidlet. So if you need to, you need to. But we already get out at 1.
Yeah, well, yeah.
That's 15 minutes early. My greatest sadness is that I don't get to keep the juniors right till 1:15. Yes.
I have a question. This is just kind of related to size. Are you on duty in the house today?
Yeah, why?
Like during like what time?
This afternoon I'll be on duty.
2?
Sure.
Okay. If I hand in my sheet, will I like then?
Oh, I didn't say that when I was over there. If you didn't hand in your sheet today, the last time that I can drop someone from Saturday night prep is Friday at 7 o'clock. So it has to be in by tomorrow before prep. So this afternoon's fine. Tomorrow afternoon is fine. Put it in my mailbox with their name on it if I'm not around for some reason.
I thought it was Friday after.
Sometimes teachers will do that, and Ms. Mertland will let it go, or Ms. Allen will let it go, and sometimes they won't, because I've done that, and Ms. Mertland said no. They didn't get it in on time. I think Ms. Allen so far hasn't done that, but I'm not sure. So I say 7 o'clock to be sure. But Ms. Allen also doesn't, I don't know if she knows the rule, because Ms. Mertland made the rule. So if you hand it in after prep, I'll try. Okay. What time is it? 11:30. Oh, hold it. I was so confused. I was looking at that clock. What clock was I looking? It was wrong. I thought we were in period 3.
No, it's 2.
We only have 15 minutes left, which means I think
It says you need an iPad.
for a phone, we use SparkView. We've all used now at least one SparkView on our phones. We do have iPads that are out there. I would like you to start. You're going to need 2 masses. They have to be the small disc masses, not the big ones. It doesn't look like there's anybody out there. I may quickly tell you to leave because I didn't book the lab. I was just hoping I could sneak in the last 20 to 30 minutes of class. It's actually the last 15, but this will give you a chance to figure out how to get set up. I have the sheets, so let's go out there and just start seeing if we can do the lab. Do you want a tall chair? Are you good on that?
I barely did anything. You just sat there. Oh, I did. That's why I said big muscles. They are. Oh, I almost got it. Because your muscles.
So
doing Rebel Rampage.
It was last.
It's a Viking competition.
Oh,
What about you?
spiteful.
You still doing a Kaizen app stream?
Bro, we realized it was a horrible idea.
Terrible.
I saw that.
Yeah, that was probably the dumbest idea I've ever
That
had.
was, I think that was the one.
I was really tempted to say that, but I just wanted to see.
Bro, shut your plate
Didn't see
for
your
your
email?
downfall.
No, I wasn't praying. I was just like, I was just curious. I was curious. to see how
Was
it
it existing and preventing the
Thanks a lot.
Do you think she'll get mad at me if I just wear like a sport top? Yeah, she would. What did it say, brand on it?
Yeah. Here, take your track. Put it back.
I hold it on.
Yeah.
What?
I don't
Whose
know.
track is that? Ben, whose track is that right
What do we
there?
do with this?
You can put that back? Keep it. We're gonna do a little bit more next day.
That was a quiz. So
Pardon?
I thought it was a quiz.
Oh, I lied. I just wanted to put their stuff away.
Why is dumb?
No. We're gonna weigh the card next day.
Where's my binder?
And you're gonna measure it. Because, hold the card red, put it red, everyone has to do it, but, the card stuff around, hold the red, put it up, put it up.
Thank you, Doof.
We said measure the previous calculators, not to know height, we know position. You know, the velocity of the
No, that wouldn't allow you to calculate.
it could, okay.
Yeah, 1/2 mv squared.
Okay.
Height,
Let's go.
you're not directly dropping it, going
Yeah.
down, you need a lot more data because you need the angle, you use doing the math. I will,
too
you
late.
will need to record the height and.
Wait, so that's all?
So we're gonna get that next day.
What?
Bro, am I gonna be late?
Unreal chat.
Miss Baltiani's actually.
Yo, Ariel, is Casey in your group?
No.
No?
He's in the other group.
No.
I know. I wish that he was in my group.
He's
too.
with Charity.
No, he's like, you kind of like comprehend how excited he is when he's like gonna see his kid. He's like super excited.
Oh, that's in what way?
No, no. No, but like, because they literally like the same things and they just spend like time together talking.
No, I love my buddy so much.
Who?
She protected me from a branch.
No way.
Yeah, I told Kieran, I was like, step up. She protected me from a branch.
That's yours, by the way.
What?
No, all those things.
Oh, you stole my eraser? This is Zane's
No,
sharper.
that's really yours. I
No,
don't know.
he's
I
like super high. He pulls up to me in the morning and says, "Here, go, I'm going to see my kid in the morning today."
Wait, that's so funny.
That's sweet.
Yes. Okay.
Oh my god.
Why is that his? Okay, we messed up on the graph.
It's fine. It doesn't matter.
No, I want to know.
Who cares though?
Who cares?
But that was a big one, wasn't it? Maybe. No, I don't know. Okay. Three more. Okay.
Yeah, I have a sense I will do really well at the University of Calgary next year. On what do you base that?
Yeah.
Not previous experience.
No,
Anyway,
that's odd.
yeah.
Thank you, Jim, for all of
Hey,
your
no,
work.
no, we keep working, chipping away.
Chipping away.
Yeah. Hopeful. Hey, Chloe. Well done today. Nice to see that promposal. As an English teacher, can I tell you that's a portmanteau? Anytime you take two words, you turn them into one. Like breakfast and lunch becomes brunch.
Take over the world.
Prom and proposal becomes
That's
promposal.
not
It's a
possible.
portmanteau.